discuss about the metrology, underpinning manufacturing, and intriguing deliberation. We have with us our Honorable Shri B.N. Dixit, Director Sahab. So, would you like to speak two words?
Good morning. Uh, Director Legal Metrology in charge, Mr. Ashutosh Agarwal ji, Dr. Girija Mona, Senior Scientist from National Physical Laboratory, all the participants. This is very good matter that every Saturday, Dr. Ashutosh Agarwal is conveying such seminars where the lot of scientists and legal metrology officer of the department are participating, apart from the manufacturer, dealers, and different associations, where they are participating in the knowledge sharing, experience sharing, and so many other things. RSL is also the leading laboratory of the country. They have got the OIMCS certification. The legal metrology the Department of Consumer Affairs has got the YMCS certifications, and RSLs are working under the department. They are doing the testing and calibration job of the different instruments, including the weighing and measuring instrument, which are certified by the department. So this seminar is very fruitful to all the participants, including the different organizations. So I think that efforts of Dr. Ashutosh Agarwal is taking in place, and people are updating their knowledge day to day. I hope that Dr. Girja Vyas today the lecture will give the one more steps up ahead in the knowledge sharing. I wish for the success of the seminar. Thank you, Astoshi. Thank you, Dr.
Thank you.
Girja,
Thank you very much, sir, for
Girja
your
ji,
time. Thank you. Thank you
Girja
so much,
Mona
sir.
ji, and all the participants.
Thank you. Thank you very much, sir, for your kind and motivating words. Really, you are a
Thank you,
motivation
Astoshi.
and all this. Thank you very much, sir. Now, I would like to request Dr. Giza Mona, who is known for this, for her research and development, research papers, and a lot of work what she has done. I would like to request her to kindly share with us her experience, her knowledge, and the work which she has performed recently. Dr. Giza Mona, please.
Thank you, sir. Thank you so much. As I've already told you, I have a bad throat since today morning, but I'll try to be understandable as much as I can. I hope you can hear me clear.
Yes, ma'am. Yes, please.
So I'll just share my presentation. As the Association of Legal Metrology and NPL is, witnessed by probably many decades, we have been working in, conjunction, hand in hand for the growth of the country. We have also been in collaboration for some technical services projects also. Recently, we have installed the setup in RRSL Bangalore, and we will be moving forward for the other 5 centers also. I'm very happy to be in a gathering which seems to be quite ours. The meteorologists, the community is very, very specific, and there are very less people who understand the importance of metrology. So it's always good to be in our own, gathering, own community. I would try to be very, very basic, very, very generic, because the topic I chose is of quite relevance in the present scenario when we talk about Industry 4.0. So we will start from the basic metrology, and then how metrology plays a very, very important role in the manufacturing, and how do we step the smart manufacturing. So I'll just share my presentation. So are the slides moving?
Yes, ma'am. Yes, ma'am. Very well. Please.
Thank you. So the topic is metrology underpinning manufacturing, which means how we metrologists, how do we play a very, very important role in manufacturing, in making quality products, in maintaining the quality throughout the manufacturing segment. We cannot imagine our life without the products which are being manufacturing in different industries. So manufacturing is not possible without precise metrology, be it the mass metrology, be it the dimensional metrology, be it the pressure, force, temperature. So wherever we talk about manufacturing, we have to be very, very careful about the metrology. So this whole talk will cover a vast idea that how important we metrologists are towards the industrial growth of our country, how strongly we are supporting the manufacturing, how strongly we contribute to the quality assurance in the manufactured products, and how strongly we act as the backbone towards the trade within the country and across the border. So the presentation outline consists of metrology and its evolution, metrology in manufacturing. What are the concerns related to the conventional manufacturing so that we are motivated to step to the smart manufacturing or digital manufacturing? A brief introduction of smart manufacturing, then how the metrology is supporting the smart manufacturing, and a small conclusion after that. So I love this saying, everything is perfect until we measure it. So till the time you measure something, it looks to be perfect. You only get to know that there is something wrong when you start measuring it. It may be its weight, it may be its dimension, it may be its temperature. So till the time we are measuring something, everything is perfect for us. So when metrology comes into the picture, we identify the faults, we identify the defects, and we try to rectify them by correct measurements. And one more saying supports this, that if we cannot measure something, we cannot improve it. So, for continuous improvement, continuous measurements, correct measurements are very much required. So, first of all, we metrologists have to understand our importance in the quality infrastructure of the country. Then only we'll be able to speak about our subject, we'll be able to create awareness among the general mass. Okay, so we know that metrology is a Greek word which have been derived from the word metrologia. Metrology has been derived from a word, Greek word metrologia, and if at all we try to define it, we say that it is the science of measurement and its applications. So what is measurement? Measurement is, kind of assigning a number to the attribute of something. For an example, we say this object is very heavy. So how heavy is it? Till the time we assign a number and assign a unit, the statement is open. Very, very subjective kind of statement. Then this, it is very hot today. So how hot it is, we have to define it with a certain number and the unit associated. The person is very tall. How tall the person is, we have to assign a number associated with the unit. So measurement is something which has the ability to quantify different attributes of an object, a person, the environment, the components which are being manufactured, you name it. And if at all we can measure the particular attribute, it becomes easy for us to define that particular attribute in terms of number associated with the unit. Okay. And metrology, what does metrology do? Why do we need metrology? So metrology establishes the international standards for measurements used by all the countries, both in science and industry. Uniformity in measurements is very, very important if we talk about the cross border trade. If the uniformity is not there in measurements, something manufactured in Japan will be fail when it is used in India. So the uniformity in measurements is very, very important when we talk about globalization of business. So, metrology plays three major roles. Technical, of course, we all are technical people. We know the technical terms of metrology. Awareness creation, we have to make people aware that metrology is very, very important. Probably when the applications are coarse, we can be little liberal, but when the applications are highly scientific, we cannot be liberal. We can be liberal while weighing 1 kg of vegetables, but we cannot be liberal while we are talking about the manufacturing of pharmaceutical industry, medicines, medical equipment, aerospace segment. There we cannot be lenient in the measurements. And then comes the regulatory role. Probably legal metrology people know better than me what regulatory role the metrology has to play. And if it all we broadly define, we have three types of metrology: scientific metrology, legal metrology, and industrial metrology. Scientific metrology is mostly dealt with the NMIs of the country. Like NPL is the NMI of India, that means the National Metrology Institute of India. So, scientific metrology includes the research and development in the measurements, the research done in order to perform precise and accurate measurements, the research done to lower down the measurement uncertainty, the research done to reduce the errors, the research done to develop a new measurement method, the research done to develop a new measurement institute. So, this all includes scientific metrology. Then comes legal metrology, the reinforcement of metrology across the country done by you prestigious people comes under the legal metrology. Then comes industrial metrology, about which we will be talking. Whatever metrology is utilized in industry for designing, manufacturing, inspection, quality assurance, scrap, rework, rejection, cell approvals, whatever is kind of metrology is being performed in industries is known as industrial metrology. So, the quality infrastructure of our country includes four prestigious organizations. This is not in order. This is not in any order. There is no hierarchy. It's just it has been arranged in such a way that they all fit in the same slide. Okay, so the National Metrology Institute of India is CSI National Physical Laboratory. We work for the maintenance and operation of primary standard for realization of SI units. Okay, then comes BIS, Bureau of Indian Standards. Those people work on the documentation of standards. We work on the physical and practical realization and maintenance of the standards for SI units, and BIS work for the documentation of various kind of standards. We also know them as IS something something. Okay, and then comes legal metrology, which works for the reinforcement of metrology down the line across the country. Then comes NABL, National Accreditation Board for Laboratories. So these four organizations, hand in hand, work to strengthen the quality infrastructure of India. We four altogether make the quality infrastructure of India. We four are responsible for the growth of metrology across the country. We four are responsible for manufacturing of quality products. We four are responsible for the cross border trade without any kind of rejections. So we four work in close collaboration for the growth, socio-economic growth of our country. So as India has an NMI named as National Physical Laboratory. Similarly, other countries also have the NMI. The names are different. Okay. So as in India, we call it CSIR, National Physical Laboratory. US people call it NIST. Germany people call it PTB. NPL, Britain people call it NPL UK. France people call it LNE. Italy people call it Vinim, some Thailand people call it NMI Thailand, Japan people call it NMI Japan. So we, being the National Metrology Institute of India, work in close collaboration with the NMIs around the world for the growth of the country on the international platforms. Okay, so we work for the apex level scientific metrology, as I told you, the research and development related to metrology. Then we provide apex level calibration services to the various users across the country and cross the border to the SARC NMIs. Like we provide the traceable services to NMI Bhutan and Nepal, Bangladesh, Sri Lanka. So I mean, it is very difficult to imagine that our traceability is flowing down the line to the SARC NMIs and affecting their manufacturing and trade. Whatever is being manufactured and traded in Sri Lanka is traceable to NPL India. So, if at all NPL India, by any chance, because of any ignorance, commits any mistake while calibrating their instruments, the results are reflected at the somewhere at the bottom in Sri Lanka. So I'm speaking this, I'm telling this because meteorologists have a lot of responsibility on their shoulders. If at all, because of any reason, we deviate from the measurements, we are not much careful about when the measurements are being taken, the cost to be paid may be huge to the user. So we have to be very, very careful. Then NPL also work for the technical consultancies, and also we keep on conducting various training programs. These days we are also conducting training programs on skill under the skill initiative of Government of India, and the regular training programs are also there. So the National Metrology Institute, which is known as NPL, we maintain our meteorological capabilities by providing calibration services, research outcomes, and we make sure that whatever measurements are being done, they cater to the requirement of the customer. So various organizations are being catered by NPL, like starting from the automobile giants, then the manufacturing giants, then the pharmaceutical industries, then the government research and development laboratories, then, as I told you, SARC NMIs. So we provide traceable calibration services to a vast segment of uh, variety of users. So, if at all we talk about the basic terms of metrology, the first term comes into the picture is accuracy and precision. I hope all of you would be clear in this. If at all we have some kind of doubt, let us focus on the first left side diagram. Okay. So the first, for an example, there are 4 dots, and these dots are the measurement values. The 4 dots are the measurement values, and the central red dot is supposed to be the true value of the measurement. For an example, we are supposed to make repeated measurements for a block of 10 millimeter length, nominal length. The nominal length has to be, the true value has to be 10 millimeter. But if at all we make the repeated measurements, it will never come 10 millimeter exactly. Either it will come 10.0001 depending upon the resolution of the instrument using which you are measuring it, or it will be 9.9999 something. Okay, so for an example, we take 4 sets of measurement, and in the first diagram, we see that all the 4 black dots are very, very close to the red central dot, which means the measurements are close to the true value and close to each other. That means accurate and precise. The second diagram shows that all the 4 black dots are close to each other, but they are away from the central red dot, which means the measurement set is precise but not accurate. Look at the third diagram. There are also the 4 black dots. They are scattered, but they are still closer to the central red dot, which means the measurement set is accurate but not precise, as the measurements are not repeated. Fourth diagram says that all the four dots are scattered and also they are away from the central red dot, which means the set is neither accurate nor precise. That means the worst set the operator is getting. So this has to be completely discarded. The fourth set has to be completely discarded. And the best set, ideally, is the first set where all the four dots are closer to each other and close to the true value. So whenever we make measurements, errors are incorporated automatically. Whatever precautions we take, we cannot make an ideal measurements. Even if we take the best kind of precautions, maintaining the best environmental conditions, asking our best, most skilled operator to take the measurements, then also there is a chance of errors in the measurement. Those cannot be removed while we are taking measurements. Those can be minimized by the statistical analysis, but those cannot completely be removed while we are taking the measurement. So if you look at the right side upper diagram, you will see that when the measurements are accurate and precise. Okay, let me tell you one thing, that whenever we take measurements, there are two kinds of errors which are incorporated: random errors and systematic errors. Random errors are those errors which do not have a certain pattern. We cannot estimate the reason of those errors. Whereas systematic errors are those errors for which we know the pattern, and yes, we can also make an idea, have an idea that, oh, because of this reason these errors may be coming. So if the set is accurate and precise, there will be less errors. The random errors will be less and the systematic errors will be less. So if the errors are less, the precision and accuracy will be high. Look at the central picture. There the set is precise but it is not accurate. So the random errors are less because the measurements are being repeated and they are closer, but they are not close to the accurate, the true value. And the systematic errors are high. So the precision is there, but accuracy is not there. In the third diagram, the measurements are scattered and also they are not close to the true value. That means again the worst set of measurements. So the random errors are high, the systematic errors are high, no precision, no accuracy. Okay, so now if we talk about repeatability, repeatability is very, very close to the precision, but there are certain conditions associated with repeatability. Repeatability and reproducibility have a very marginal difference. Repeatability has its own conditions. Reproducibility has its own conditions. The data would be, the measurement observations will be repeatable, would be called repeatable when they are fulfilling the repeatability conditions, and they would be called reproducible when they are fulfilling the reproducibility conditions. Repeatability conditions is you take the measurements after a shorter span of time, the operator is same, the instrument is same, the place is same, the environmental conditions are not much deviated. Whereas reproducibility says you take measurements after a longer span of time, you can change the operator, there is a slight change in the instrument also, and the environmental conditions are also much deviated. So even if the data is repeating itself, it would be called reproducible. So repeatability and reproducibility and precision, they are having a very, very hairline difference between them. Not much different. But we have to be very, very careful that in which kind of measurement we are taking repeatability into the consideration, and in which kind of measurement we are taking reproducibility into the consideration. There are certain kind of measurements, electrical measurements, they take reproducibility because they take the data continuously, probably for 1 month at sometimes. So if you take the data for 1 month and at an interval of 1 day, so it would be reproducibility checking. But if you take the measurements, for an example, for 2-3 hours and continuously repeating the measurements without much break, then the data will be then you would be saying that I'm checking the repeatability. Okay, then comes traceability, the most important phenomena of metrology, which is to be understood very, very thoroughly by all of us. Traceability is the unbroken chain of comparison to the SI units. Often, very often, we neglect this, but this is one phenomena which which gives the authority to your measurements. Till the time the measurements are traceable, the measurements are not reliable. Till the time the measurements are not traceable, there is no authority associated with the measurements. So, unbroken chain of comparison to the SI unit means that your measurement should be linked eventually to the SI units. It is not necessary that each of your instrument will be calibrated, or each of your measurement which is being done should be directly traceable to the, should be directly related to the SI unit. But yes, there may be a long chain, and eventually the traceability should go to the SI unit. Why? As I told you, just to give a sense of reliability to the measurements being performed. If there is no existence of traceability, people will do whatever they want. There will be no verification of the measurements. For an example, say we have, as I told you, we have recently installed a setup for line scale calibration using laser interferometry in RRSL Bangalore. So how does the traceability flow there? Kindly understand this example. How the traceability is being maintained at RRSL Bangalore? Say for an example, a customer with a name A comes to RRSL Bangalore to get its line scale calibrated, right? So how the traceability is being maintained? You have a setup for line scale calibration, you have a laser interferometer there, you have the temperature, humidity, pressure sensors there. So everything has to be traceable. First, you have to make sure that your setup is traceable to SI unit. Beforehand, you give the calibration services to your customer. So customer A comes to RRSL Bangalore for calibration of a line scale. RRSL Bangalore legal metrology officers, they put the scale on their setup, use the laser interferometer and calibrate that scale. Now, the customer A's scale is traceable to RRSL Bangalore. RRSL Bangalore's laser head is traceable to NPL India's primary standard. That has been calibrated by me. That laser has been calibrated by me using the primary standard. Okay, so RRSL Bangalore's laser head is directly traceable to the standard of uh, primary standard at NPL India. Also, the associated sensors, temperature, humidity, pressure sensors are traceable to NPL India. So eventually what happened? Customer A's scale is traceable to the primary standard of India. So this is how the traceability is being maintained. And also, whenever we talk about traceability, we never talk about it as a flow chart. We always talk about it as a pyramid. It is pointed towards the apex. Why? It is always becoming pointed narrower towards the apex, because the as we come down from the apex of this triangle or the pyramid, as we come down, the associated errors and the associated uncertainties, they keep on adding. The SI unit ideally has no error, ideally has no uncertainty. But the primary standard had some uncertainty. Then the national standard has uncertainty more than primary standard. Then the reference standard has uncertainty more than national standard. Then the working standard has uncertainty more than primary standard, national standard, reference standard. And the measuring instrument has highest uncertainty. So that is why it's a pyramid. It is never a flow chart. There is a logic behind making it pyramid. Why? Because as we come down the line, the errors and the uncertainties keep on increasing. Why they keep on increasing? Because every time you you perform the calibration, the standard again which the calibration being performed will always contribute to the uncertainty of the device under calibration. Okay, so that is why it is being increased down the line. Now, what is calibration? Calibration is comparison of a device under calibration with a standard under specified conditions. Comparison is not calibration. Calibration needs to be performed within specified conditions. Okay, so for calibration, why do we have to train people? We have to make them realize that calibration is not simple measurement. Calibration is something to be done very very uh, in a serious way. Then comes uncertainty, measurement uncertainty. All of us know that measurement uncertainty is a band, is the are the different kind of doubts associated with the measurement observation, and those doubts may be caused because of various factors. So whenever we have to calculate measurement uncertainty, first of all we identify the error sources, then we calculate their contributions, and then we specify that this is the associated uncertainty with this particular kind of measurement. So how the metrology was evolved, why it was needed, even it existed in the old civilization. So people used metrology there also. So how do they use? They as we know that in old times the king was everything. So king's organs were used as the standards to measure something. So in old scenario also people relied on measurement, but as I told you, it was like not that uniform because we were not technically advanced. There was no science, there were no instruments. So the easiest way was, as the king was the most powerful person in the particular empire. So the king's hand, king's foot came from there only. So the king's foot and king's hand, they were taken as the standard. But this was fine as long as accuracy and precision were not issue. uh, what happens in this was, say for an example, a king which is in African countries, usually those people are giant, and another king which is in who is in Bhutan. So the king who is in African countries has a longer arm and a larger foot in compared to the king who is in Bhutan having a smaller arm, smaller foot. So till the time the trade was not cross border, the accuracy and precision were not required. It was fine. It was it was managing the things. But as we grew, as we kept growing, the measurement kept growing. When we started making advanced weapons, machines with interchangeable parts, we performed scientific investigations, then we needed universal standards. As I told you, cross border trade can only exist when there is a uniformity of measurement. That is why we talk about mutual recognition agreement, mutual recognition arrangement. That means the measurements performed in a country would be acceptable in another country. So as we grew scientifically, we wanted to make precise measurements. And when it came to the French Revolution, the unit system came into the picture, the decimal system came into the picture, and the things really they took a faster pace. And the SI units and the precision in measurements, it started taking place from 17th century and it kept growing till 21st century. The first year was 1670, when there was a unit proposed for length measurement in terms of the terrestrial meridian. And then till 2018, the metrology kept evolving, kept evolving, kept evolving. And 2018, the new units, the new definition for the four units, kilogram, Kelvin, mole, and ampere, they came into the picture. We re you all of you must have heard redefinition of mass, redefinition of temperature, redefinition of mole, and redefinition of ampere. Earlier, what happened? Why do we need it? Why do we need this new definition? Earlier, we used to measure or realize the SI units using physical artifacts, prototype copy number 57, or the meter bar or the thermometers. But what happens is all these physical artifacts, they involve a lot of errors. They keep on degrading as the time passes. There are accumulations, contaminations. So the meteorologists propose that let us realize all the SI units in terms of the fundamental constants of physics. So kilogram was to be realized in terms of the Planck constant. Kelvin was to be realized in terms of the Boltzmann constant. Mole was to be realized in terms of the Avogadro's number. So all these physical constants, they do not have any scope of error or uncertainty. So it is always better to realize SI units in the terms of these physical constants. So in 2018, it was a revolutionary year when the redefinition of four major units, SI units, was it came into the picture. So this all, on an international front, this all is being done by the General Conference on Weights and Measure, which is known as CGPM. It is the supreme authority of the International Bureau of Weights and Measures, BIPM, which is situated in France. Okay, so BIPM is the apex body when we talk about the metrology. So it is an intergovernmental organization, and there are 59 member states who act together. They have signed it, and there are four areas: chemistry, ionizing radiation, physical metrology, and coordinate universal time, on which BIPM works. And sometimes BIPM also provides traceability to various NMIs. So in 2000, earlier, what was the SI unit linkage? As I told you, in 2018, the SI units were redefined. The left side diagram was the earlier diagram, which shows the SI unit linkages, right? So you can see that the mass was, realized by a physical artifact. Temperature was realized by the physical artifact. Length was always associated with time, because length is defined in terms of the speed of light. So speed always consists of time. But when in 2018 the SI units were redefined, you could see that every SI unit is associated with a physical constant. All the physical constants are written in the gray circles. So length is realized in terms of speed of light, temperature in speed of Boltzmann constant, intensity, electric charge, time, cesium atom splitting frequency, mole Avogadro's number, mass, Planck's constant, luminous intensity is luminous efficacy. So in some of the redefinition in NPL is working, and some of them are planned. Now comes the need of metrology in manufacturing. Why do we need metrology in manufacturing? When we manufacture something, we need to accurately define the shape and size. If at all the shape and size of the component which is being manufactured is not defined clearly, there would be issues while we assemble certain parts. Okay, and also to ensure that we have confidence in whatever we are manufacturing. For an example, a designer has a design in his mind, and he has, decided some dimensions, and he passes the drawing to the person who has to manufacture it. Till the time the person who is manufacturing the component doesn't understand the drawing correctly, that person will not be able to make it correct. So there should be a very, very, thorough understanding of the design which has been provided by the designer. So that builds up the confidence. Okay. And metrology establishes the link between, it establishes a strong link between the designer's intent and the product which is manufactured. Does it function as it was supposed to function, or it is malfunctioning? The designer thought that I will design this product and it should function this way. The manufacturer understood the designer's drawing in a correct way and manufactured the component. Now the component has been manufactured. If the component is functioning the way it was supposed to function as per the designer's intent, the quality is maintained. But if the component is not being, is not functioning the way it was supposed to function, the quality is compromised. Now the fault is at whose part? Whether at the designer's part, whether at the manufacturer's part, or whether at the person who inspected the component. So all the three areas, people involved, all the three steps should have a strong understanding of metrology, should have a thorough understanding of metrology, and they'll have to, realize the importance of the person who is giving them the input in terms of metrology. The person who is operating the instrument machine to manufacture the product has to understand the designer's drawing very, very thoroughly. The person who is inspecting the manufactured component has to understand the designer's drawing and the manufacturer's thought. So, measurement is the most fundamental concept of science and technology. Also, it ensures the reliability. So, that if the measurements are reliable, you can also control the processes to maintain the quality, and also the risk of false decision making with coarser sampling and higher measurement uncertainty is reduced. Why? Because false decision making is, for an example, a component which was to be rejected has been selected in the lot, and the component which was to be selected has been rejected by mistake. So this only happens when the people are not thorough in metrology. They have to be very, very thorough in metrology, and if at all they understand the metrology correctly, there will be less false decisions. Now comes a term, interchangeability. This is a very, very interesting term, and I am very much attached with this term because this is directly associated with the dimensional metrology fundamentals. I am a dimensional metrologist by profession since last 15 years. I'm too much into dimensional metrology, so anything which is related to dimensional metrology it becomes automatically my favorite. So this interchangeability is a term which is associated with dimensional metrology. How do we define interchangeability? It is associated with the products. So any part chosen at random should be fit properly with other mating part, which is also randomly chosen. For an example, 5 of us are sitting on a table. 5 people in a line sitting. They are sitting, and there is a table in front of them, and 5 distillery bottles have been placed on those tables. For an example, a person drinks all the water and puts the cap back on the bottle, and another person by mistake drops the cap of the bottle. So you can always borrow the cap of another bottle and fit in on your bottle. That means all the caps of Bisleri water bottles are interchangeable. All the bottles are interchangeable. Any cap can fit into any bottle. Any bottle can be tightened with any of the cap. So this is known as interchangeability. How it becomes possible? It becomes possible only when, please listen carefully, it becomes possible only when the dimensional metrology during manufacturing is taken utmost care. When the dimensional metrology tolerances are handled very, very seriously, then only interchangeability can be, it can brought into the existence. If there are certain compromises in the dimensional metrology, the interchangeability wouldn't be possible. You can see in the slide, one box has nuts, one box has bolts. You put up any nut, you pick up any nut, pick up any bolt, try to assemble them, they'll get assembled. There wouldn't be any issue if at all the sizes are same. Okay, if the thread sizes are compatible to each other, you have a box full of nuts, you have a box full of bolts, you will pick any nut randomly, you will pick any bolt randomly, and you will fit in them very, very easily. There wouldn't be any problem. Why? Because all the threads in the nut and the bolt, they have been cut using the dimensional tolerances into the consideration, having very, very tight dimensional tolerances, so there are no assembly issues. Similarly, tire rims, the tire rims also fit into each other without any brand specification. Similarly, the bulb holders, you have different kind of bulb holders. Any brand bulb can be held into any of the holder. So This is how this beautiful concept of traceability, interchangeability is, influencing the mass production units. When we take the dimension tolerances very, very precisely, we handle them very, very accurately, then only the interchangeability can be brought into the existence. Else, one Bisleri bottle cap will be specific to one Bisleri bottle only. They cannot be interchanged. So, as I told you, interchangeability is possible only when the components are manufactured with very, very close dimensional tolerances. So, how measurements play very, very important role in manufacturing? They ensure quality, reduce waste. When the quality is maintained, of course, there will be less wastage. Okay, and the wastage is less, the productivity will be higher. The productivity is higher, the profits will be good, and wherever you make a quality product, it increases the customer satisfaction. Quality is directly related with the customer satisfaction. So, can you imagine? Measurements are directly related with the customer satisfaction. Even if the mobile phone you are holding in your hand has been designed by keeping into consideration the size of your palm, how comfortably you can hold a mobile phone. Mobile phones which are tough to hold, they are not existing anymore in the market. So that is also, that is also an aspect of measurement, that the palm size and the mobile phone, they should be compatible to each other. There shouldn't be any discomfort while holding a mobile phone. Even the mobile phone's screen's roughness, that also has to be taken care, so that it doesn't get affected with, by small impacts. Also, the, inside the integrated circuits and whatever is there, that all comes into nanometrology. The contact points dimensions are also important. The ICs, they have different contact points, and the dimensions of the contact points are also differences. Also, the dimension of the contact points are also very important, so that the circuit works in a correct way. So the measurements are directly related with the customer satisfaction. It is only the matter of being awareness about the beauty of metrology and measurements. So, as I told you, metrology is an indispensable part of modern manufacturing infrastructure. As the products become complex, they need high quality control. And high quality control is directly related with elimination of errors and improving the processes. Okay? And that can only be possible with the precise and traceable measurements. So, the metrology keeps one principle in mind: make it right in the first time. There is no scope of rework, there is no scope of wastage. The product should be right for the first time. And the life cycle of a product is supported by accurate and precise measurements. As I told you, there are certain kind of products who become fail during the service because the measurements were not taken care properly. So, in service failure of a component is very, very dangerous. Can you imagine an aircraft is flying in the sky and some component fails there? It would be catastrophic, causing many people's life. So, if during manufacturing we somehow ignore the aspects of metrology, the, the consequences can be dire. So, standardization of parts, processes, and parameters when we talk about manufacturing and metrology is very, very important. As I told you, it is very less likely that a single manufacturer is making all the components and getting them assembled. It is very less likely in these days. So, what do they do? A survey says that 70% of the components used by any industry are processed by are produced by other industries. So, what do? They bring those components, get them assembled, and they make a product. So, if at all those components are not being treated correctly from the aspects of metrology, the assembly would be a fail, big fail. So, all the small manufacturers also have to be careful. Yes, there are tolerances, allowances, But if the manufacturer is not thorough about the importance of those, the tightness of the tolerances and allowances, he manufactures the component which is beyond those tolerances and allowances, the whole assembly either wouldn't be possible or would be a fail. So as we advance technologically, scientifically, we need to push the metrology towards a higher step. As I told you, if the application is coarser, metrology can be compromised. But if the application is highly scientific, metrology cannot be compromised. In automotive sector, metrology cannot be compromised. Defense sector, metrology cannot be compromised. Pharmaceutical, metrology cannot be compromised. Semiconductor, metrology cannot be compromised. Diagnostics, metrology cannot be compromised. Imagine an X-ray machine or MRI machine doesn't function when it is required the most because of any metrological ignorance. What would be the consequence? Imagine while making a medicine, the composition of medicine, for an example, says that constituent A should be 2 nanograms. And because of any reason, constituent A becomes 2 micrograms, the person may lose its life. Okay. Similarly, in automotive sector, there are various components which undergo fatigue failure. Fatigue is directly associated with the surface finish. Why? Because the fatigue crack is initiated from the surface. You can always see this. If there are two components, one has a poorer surface roughness and you put them under fatigue loading, the rougher component will fail early. If the surface roughness has been not kept into consideration and a part fails in service under the fatigue loading, it may cause accidents. Defense sector, we also provide various calibration services to the defense sector. Sometimes they come to get calibrated. They call that it is a kind of protector which measures the trajectory of the bullet which is coming from the gun. If at all the item is not calibrated correctly at NPL, the bullet will hit somewhere else instead of hitting the target. So you have to be very, very careful about metrology. Not the number, but the unit also. There have been certain incidences in past that because of the mistake of the unit, there are huge losses, scientific losses. There is an incident of NASA. It was, they launched a satellite and they calculated the trajectory, but the units of calculation were different. Say, for an example, they calculated meters in millimeters or centimeters. So what happened was the satellite was lost in the universe. It did not reach its targeted orbit. Why? Because the trajectory calculation was wrong, not because of the number, because of the unit. So metrology is both the number and the correct unit. Unfortunately, there is no coherence between laboratory metrology and industrial measurements. The metrology which is being observed in laboratory with skillful operators, with the best environmental conditions maintained, with the best instruments we could procure, they are very different from the industrial measurements. So if we are providing traceability to industrial measurements, there has to be some coherence. There is a huge gap between state-of-art facilities and industrial requirements. Okay, so it has to be, it has to be in coherence, the laboratory metrology and the industrial metrology. First, in terms of the knowledge. Second, in terms of the infrastructure. Industries have a kind of thought that if at all they invest more in metrology, there will be, there will not be much profits. There will not be higher profits. But what happens if at all we strengthen our infrastructure? There may be a temporary drop in productivity initially, but in long terms, there will be significant productivity gains. So the industry people are also to be counseled this way, that in any case, if at all they invest in metrology, it is going to give them higher gains in long terms. And also, Advanced metrology techniques are always better than conventional measurement processes. If at all, we talk about the tighter tolerances. Okay, so if we want to handle the tighter tolerances, we need precise instruments, and those are essential these days. If we talk about the smart manufacturing, production metrology, inspection methods, measurement algorithms, and tolerance representations. Inspection, manufacturing eventually relies on inspection. So, inspection is nothing but metrology. It is an integral function of the production. So, what happens in inspection? They examine a part whether it conforms to the design specification or not. As I told you, the designer, the manufacturer, and the inspector, all three have to be in coherence. In mass production, industrial inspections become most important because they involve the interchangeability of the parts. If at all the inspections are not being done properly, the interchangeability would be disturbed. Okay, and to achieve interchangeability, the dimension of the components should be well within the limit given by the designer. Okay, and inspection can be done by two ways. Either you do the actual measurements or you do the gauging. Gauging is faster, actual measurements takes time. So most of the times the inspection involves gauging methods. You use ring gauges, you use length bars, you use gauge blocks and other go-no-go gauges, plug gauges, thread gauges to inspect the various components which are being manufactured. So as I told you, today's quality is tomorrow's reputation. Market reputation is completely dependent upon the quality. So the inspection is, it influences the quality in a very, very significant way. It ascertains that the part conforms to the standard, interchangeability is there, customer goodwill is there. There are, if at all there are some inadequacies in manufacturing, those are to be identified and eliminated. Okay, acceptable parts are to be taken care of, and reduction in scrap. That means design in a correct way, manufacture in a correct way, inspect in a correct way, give quality products, scrap those which are not as per the quality, rework on them, and again produce quality uh, products. Okay, good quality raw material and equipment are to be purchased. And if at all, by any chance, after taking this much of care, the parts are being there are some defective parts, they are to be reworked. So there are certain challenges in trend in the manufacturing industry. The trends are like, we need to increase the integration, reduce the measuring time, there should be automatic data processing. If at all we talk about metrology, errors should be less, uncertainty should be less, measurement uncertainties are to be verified. Okay, measuring techniques are to be they are supposed to be advanced. And then inaccessible parts, if a component is very complicated, you cannot measure everything using a scale or a vernier caliper or a micrometer. You ought to have an articulated coordinate arm measuring machine or a rocker arm measuring machine or a portable CMM to measure the inaccessible part, and that is an advanced measuring instrument. Okay, so metrology, and then communication, and then planning. So metrology in manufacturing plays a very, very important part. We can even optimize and control the processes which are being used in manufacturing. It is not an isolated field. Okay, and manufacturing and measurement, they are supposed to be as close as they can in order to limit the time wastage. What are the concerns related to conventional manufacturing? Those forced us to target the smart manufacturing. The concerns are flexibility of design is less customization, production time is longer, information passing the information is very, very slow, optimization of services is limited, there is no communication and analysis of performance, real-time data extraction is not there, because of which the false decision making is there, digitalization is less, integration is less, and getting data is a tough task. and floor operations are tracked and handled very in a difficult way. The conventional manufacturing involves a lot of manual processes, because of which they become less efficient and less productive. Human involvements cause errors and uncertainties and eventually affects the quality assurance. Scaling becomes very difficult in traditional manufacturing. Okay, and if the product loses its quality, the lack of trust is there in the stakeholders. Automation is less, integration is less, equipment maintenance and inventory management becomes tough and at times unmanageable. So there is a quick comparison between traditional manufacturing and smart manufacturing. As I told you, traditional manufacturing is manual process involving manual processes, smart manufacturing digitalized. Traditional manufacturing is time consuming, data is scattered, isolated operations, whereas smart manufacturing is faster, integrated operations are there. Traditional manufacturing, there are frequent machine failures, whereas in smart manufacturing, machine failures are less because there is real time data tracking. The moment the machine fails, you get an indication that, oh, this part of this machine is not working, production has been stopped. You go and rectify that and you start manufacturing again. Reduced productivity may be there in traditional manufacturing. In smart manufacturing, productivity is better. Poor customer satisfaction, traditional manufacturing. Smart manufacturing, customer satisfaction is higher. As I told you, that there is a scope of flexibility and customization of whatever products we are making. Poor resource utilization in case of traditional manufacturing, better resource utilization in case of smart manufacturing. Okay. In traditional manufacturing, unpredictable downtime, whereas in smart manufacturing, the downtime is predictable. Again, because there is a real time data accessing. So, smart manufacturing, if we talk about, is consisting these components: cloud computing, big data, system integration, Internet of Things, digital manufacturing, additive manufacturing, robotics, sustainable manufacturing, and augmented reality. It employs computer integrated manufacturing, and which provides rapid change in designs and digital information technology. So smart manufacturing involves smart factories, which consist of systems having the provisions of modeling and simulation, strong cybersecurity. If at all you use a lot of data, that data has to be secured also. You cannot leave that data like that somebody else can access that and control the things. So that has to be governed with strong cybersecurity and network sensor modeling also. Real-time data collection and processing and making decisions depend upon that data collection is a very important component of smart manufacturing. So it makes the industry more efficient, profitable, and sustainable. And also, it fulfills the customer need. So if we want to define smart factory, we would say that it is a digitized manufacturing facility that uses devices, machineries, and product system to collect and share data continuously. So the whole game is collection of real-time data, analyzing that, taking decision, improving the process, and making the quality product. In short, smart manufacturing or smart factory is a game of using advanced devices, advanced sensors, real-time data collection, analyzing data, taking decision on the data, and improving the processes. Okay, so main benefits are the efficiency is increased. How the efficiency is increased? The downtime is less. Why the downtime is less? Because immediately you get an indication that the machine has been broken down. Okay, so the downtime is less. You rectify that machine, get that repaired. It increases your productivity and saves the energy. Transportation is smart. You can always optimize the inventory levels and reduce the scrap. Space is optimized, labor cost is reduced, there are no human interventions, so the drop in quality is less, and the product can be customized as per the requirement of the customer. Then comes the proactivity of the system, proactivity of the operators. The turbulent and unpredictable business environments cause critical situations and huge financial impacts. If at all you are able to predict the market trends, you are able to predict the customers' preferences, you can work proactively in a better way. So, for that also, you need to have a lot of data, and that too a secured data. So, these tools which are used in smart manufacturing diagnose root causes of the problem, recommend possible solutions, and encourage the product proactivity. Now comes the smart decision making. There are various digital algorithm, digital learning, machine learning things are used in the smart manufacturing. So the, it becomes self decision making and self executing because without any human involvement. Okay, the capacities of the machine exceed humans, and they can take smart decisions. And when they take real time data, they predict the data, they use the algorithms, they can make better decisions. There are various components of smart manufacturing. How do we decide that this kind of a manufacturing would be called smart manufacturing? So there are various components. Like one of the component is industrial internet of things. Okay, it focuses on the industrial use of internet of things, connects the physical systems over the internet. It includes sensors, actuators, their monitoring, process control, and how the data would be stored in the cloud, allowing and how the communication would take place, and they aid in the production planning and scheduling. Even in the maintenance part, they identify the faults and take the decision and improve the human machine engagements. This also enables the customers to see the visual display of the products and procedures for advertisement purpose. So internet of things is one of the most important component of the smart manufacturing. Then comes big data analysis. As I told you, there is a lot of data in the smart manufacturing. Lot of data in the smart manufacturing. Okay, real time data is being taken, being analyzed. So it is like, for decision making, there should be there should be good provisions to analyze this huge volume of data. So the big data analysis helps the manufacturer to identify the present state and reason for the failure of the product, why the product failed amongst the customers, and how it can be, it can have a good uh, reputation amongst the customers. So they can even analyze the shopping behaviors and interest of the customers. This is also a part of the data analysis in the smart manufacturing. Artificial intelligence. Each one of us know that how artificial intelligence is enveloping everything around. So it is being used in the modern era. So it is being used in the modern era, like, by increasing the human robot engagements and minimizing the involvement of human in hazardous areas, like wherever we deal with the harmful chemicals or gases, we can use the artificial intelligence there. The AI systems can decide and optimize the work schedules. They can stop the production at any time, they can restart it. You feed the way you want, and it will work the way it should. Then comes the cyber physical systems. As I told you, security is very, very important. So it involves the integration of computation networking in physical processes, and it is used in aircraft, automobile sector, transportation sector, and construction also. Then the use of smart sensors. Without smart sensors, smart manufacturing is nothing. So smart sensors are used for the scientific inputs and data processing, like RFID, that is also a smart sensor. Okay, barcodes, those are also smart sensors. So all of them are being used in the smart manufacturing. They help in identification of the part and the process. We all of us know that we use a laser to scan the barcode on the product, and you get the details of all the product. You don't have to go into the detail or go to the person specific to know about the product. So these all are the contributions of the smart sensors to the smart manufacturing, additive manufacturing. It is all up, it is probably the most uh, fastly emerging trend of medical fast emerging trend of mechanical engineering in the manufacturing. So additive manufacturing we also know as 3D printing technology. You feed what happens, like, you have a part in your mind, you make the CAD drawing, feed into the printer, and we have to, feed the material by using which we want to make any component, manufacture any component. You feed the drawing, and the printer layer by layer manufactures the part. How beautifully it manufactures the part. Additive manufacturing has other advantages also. There is less, wastage while we manufacture any product using additive manufacturing. So additive manufacturing is also a key component in smart manufacturing. The for more the the most important contribution is it can do the reverse engineering. Reverse engineering additive manufacturing is much easier. So additive manufacturing is a very important component of smart manufacturing, and there are lot many provisions to play with it. Then virtual reality and simulations. Of course, we know that the simulations are very important. We have to make the prototypes, simulate them, and then we can scale up the production. And manufacturing systems are flexible. They are targeted to meet the demands, like no wastage. Whatever is the demand in the market, that can immediately be fulfilled by the industry. So how do we implement the smart manufacturing? The main goal of smart manufacturing, as I told you, the whole game is of data. We collect the data in real time and improve the factory. Another very important concern, we have this kind of thought in our mind that if at all the computers or the artificial intelligence or smart sensors come into the system, there will be unemployability. People will be unemployed because the system will throw the humans out. No, there will be no threat to the employment. There will be no threat to the jobs to the humans. If at all we fully emerge into the smart manufacturing, they they will not be replaced by the artificial intelligence. Rather, their capabilities will be boosted to handle the artificial intelligence and smart sensors. So there shouldn't be any threat to the youth, that if at all we technically grow, there will be less of employment. It will never be less, it will increase, because as we grow technically, the market will grow, the consumers will grow, and the trade cross border will grow. So there will be no threat to the employment. Okay. So uh, like, as per a study done by McKinsey, the manufacturing sector has 60% automation capability. So smart manufacturing can also increase the production capacity significantly. It offers several benefits, including improved efficiency, cost saving. Okay, if a machine is equipped with sensors and there are certain slowdown in production, it will highlight it, and the artificial intelligence will work accordingly. AI technologies can make certain productions to make the manufacturing smooth. Okay, there are greater flexibilities, better human machine collaborations, and operational efficiencies will be increased. There are certain things to be, certain concerns, I would say. Okay, so it is like, it involves a lot of cost. The upfront implementation on the first hand involves cost. So mid-sized companies, they're kind of, not interested in that. But in long terms, as I told you initially, what smart manufacturing is implementation of better measurement systems during manufacturing. So investing in measurement systems may make the other person feel that no, it is costing me too much, I shouldn't do this. But in long terms, it will always give you benefits. Now, if we talk about industrial metrology, since smart manufacturing is all about industrial metrology, so there are various modes which are to be implemented in the industrial metrology to make it smart manufacturing. Offline measurements. The measurements, what we do usually, what we do is we make the components at shop floor, we take them to the inspection room and measure them. Okay, so there is a gap between the shop floor and the inspection room. It is completely dependent upon the human element. That means time taking process, involvement of human errors. Then comes inline measurement. Inline measurement is automated and precise measurements in the production line itself. You manufacture the system, it will be measured. Then if there are certain machining, there is certain machining required, the machining will be done, again measured. Then again a process will be done, again measured. Until the time it reaches to its final stage, inspection will have a very minimal role. Why? Because it has been measured at every stage of manufacturing. So inline measurement is the best kind of measurement approach. Then comes online measurement. Online measurement also takes place continuously, but not directly in the process. Probably we provide a small bypass branch because of the limitation of installing the measurement facilities in the production line itself. Okay, and then comes at line measurement. It is somewhere between the offline and online. At line matlab it will be not, it will not be in the production line, not will be in the bypass line, but somewhere closer. So it involves less of the time waste. So what were the milestone in manufacturing metrology? I'll be talking about the, this is not, this is not all about the metrology, since as I told you I'm a dimensional metrologist. So I will be talking about the aspect of dimension metrology. So what were the milestone in the manufacturing metrology earlier? We had calipers, we have universal measuring microscopes, profile projectors, comparators, form testers, incremental length measuring devices, coordinate measuring machines, optical metrology, and laser interferometer. But now, if we talk about modern metrology, many of them have been they have been obsolete. Many of them have been obsolete. If we talk about Industry 4.0, now we prefer using fringe projections, chromatic white light sensors, white light interferometry. White light interferometry is a beautiful metrology technique. You can measure in fractions of nanometers. We have a white light interferometry based optical profiler in our lab, so it can measure in the sub nanometers. It can measure the surface roughness, it can measure the step height, it can measure the grating. It is a completely non-contact optical method to make measurements in the sub nanometer range. Then comes computer tomography, beautiful technology. It is also non-contact technology. What happens is, you have, it is known as X-ray computer topography. You have an X-ray setup. You keep the component in front of that X-ray setup. Behind that there is a screen. The X-ray falls on the component and it gives you the whole inside outside drawing on the screen, and then you can analyze it very beautifully on the screen itself. Then optical 3D measurements, multi-sensor metrology, which is known as Metrology 4.0, very closely supporting the Industry 4.0, micro and nano metrology. Okay, so measurement plays an important role in Industry 4.0 strategy. As we have 4.0, Industry 4.0, similarly we have Metrology 4.0. Okay, so Metrology 4.0 includes the use of multisensory elements, as I told you, additive metrology. So Metrology 4.0 and Industry 4.0, they are the synonyms of each other, and Industry 4.0 is somewhere very close to the smart manufacturing. And information rich metrology, artificial intelligence, automation and robotics, okay, communication of measuring and manufacturing elements, the measuring systems, those who send the information, so that the processes can be optimized and controlled in a better way. There are some pictures you can see on the slides, and these pictures show some of the measurement devices frequently used in the smart manufacturing. First one is coordinate measuring scanner in the automation station. Second one is 3D handheld laser scanner. It is a laser scanner, handheld laser scanner. You can scan the product and immediately you can have its drawing. And then scanner with a robotic arm. As I told you, at times when the product is very complex, there are certain parts which are inaccessible. You cannot insert micrometer everywhere. You cannot insert vernier caliper or scale everywhere. So you ought to have a robotic arm which has 6 degrees of freedom, okay, and it has a small probe, and then you have a display system with it. The probe can be inserted to much inaccessible parts. You can't imagine where the probe can be inserted. So the robotic arm is of much use when we talk about the complex products. And then optical, tactile, and laser scanners. Then we have optical 3D scanning solutions. And you can see the inline measurement solutions. You can see there is a car chassis frame only, and there are robotic arms. These robotic arms, they will touch all the accessible and inaccessible parts of the frame, and they can give you the profile of the car. The profile of the car is very important in order to maintain speed and all, so that it can maintain a better aerodynamicity. So this is an example of inline measurement solution. As I explained you, that the inline measurement solutions are to be installed in the production line itself. Then comes the articulated arm CMM, which is also known as portable CMM, a rocker arm CMM. This is a coordinate measuring machine which has a probe and which has a 6 degrees of freedom, and the probe can be inserted. This is very useful to measure the components which are not easy to bring to the laboratory. For an example, turbine blades. So if at all you want to measure the turbine blades, measure certain parameters in the turbine blade profile, it is always easier to carry the portable, the coordinated arm CMM or the portable CMM to the side on site and make the measurements. And then the fringe projection systems for topography. So how the measurement modern metrology enables smart manufacturing. It is an important aspect of today's manufacturing infrastructure. It is a crucial foundation for scientific evolutions, environment, climate, and with the simple information sharing. It is an activity which is not limited to the specialized institutes or calibration labs. So modern metrology is omnipresent. Okay, the concept of 4.0, industry 4.0, involves a very important role of metrology because it allows for the decision to be made. So the data collection, data analysis, and decision making is, this chain is a very strong component of the industry 4.0. Industry 4.0 is not possible without metrology 4.0. So the role of metrology in accelerating smart factories is very crucial. So as I told you, that till the time there is awareness, there is a lack of awareness that's what is to be measured and how critically is to be measured, the industries would not stay competitive. Okay, and the production wouldn't be efficient. So it is very important to decide that what is to be measured, what technique is to be used, how much to be invested, how much time is to be given to this particular kind of measurement. Also, in smart industries, if there are vibration and temperature differences, they can also be sensed using smart sensors, and you can also assume you can always have a kind of feeling that there is something wrong with this machine. So smart sensors can also give you an indication if at all there is some part is loose in the machine, which can affect the machining process, causing unnecessary vibrations. They can also give you an indication that the machine is having this much of problem, and it can cause problem in the machine, in the machining process. Also, the to compensate the vibration, the person, the operator can monitor the tool, which is the tool or any part of the machine which is causing vibration, and can calculate the process parameter which can be, you know, controlled to avoid the excess vibration. The sensors may be good enough, okay, but as I told you, only getting the data is not enough. Connecting the data, securing it is very, very important for the smart manufacturing. There is an example that you can, in smart factory, a GPS was attached to the forklift. Forklift is which is used to pick up the stuff and keep it somewhere else. Okay, so every time the forklift is placing something, it sends its footprints to the cloud. So and a person can very well, keep a track that where the forklift is moving, where is it putting the stuff from, where is it, taking it, this thing. And also, if there are any problems, any obstacles in the path of the forklift, those can also be identified and those can be fixed. So metrology is of fundamental importance to the future factories, okay, and it can always contribute to the manufacturing of quality products, efficient production systems, less wastage, all right, and also to the economical advantage in the early stage of adopting the smart manufacturing. So the objective is to make transition, to make the operators work and managers decisions, to make them easier. It is consented to digital marketing with the provisions actionable information to refine manufacturing processes. In smart manufacturing, the dimensional inspections are very, very important, and they are done at a measurement speed so that the process can be controlled and optimized. And if at all there is a poor inspection and the bad part is formed, which can cause a bottleneck, that can also be identified and that can be completely eliminated. So for quality control of the miniaturized assemblies, the measurement technology therefore must offer high resolution and accuracy. Reliable measurement should be there. The biggest disruption is in process measurement. So in process measurement, if we are doing, we have to optimize the production process along with the measurement very, very smartly. In smart manufacturing, real-time metrology validates the parts in the production, okay, and the main drivers are the speed and the avoidance of scrap. What happened was industry 3.0 used the fixed CMM, industry 3.8 used the articulated CMM, and industry 4.0 is using the CMM but integrated in the production line itself. There are multi-sensor measurement systems to take the real-time information, and it also provides exceptional speed and efficiency for the quality control. There are certain technologies which are being used in smart manufacturing. So these are laser line scanning. You can do the laser scanning in the production line itself. Then the structure light using the LED projectors. Then the image technology, like if at all thermal imaging and all, you can be used, X-ray and computer tomography and robots. So the conclusion is, the use of metrology will be essential from the starting points to the end of the manufacturing. Industry 4.0 and metrology 4.0 shall grow hand in hand. Precision metrology and production data is extremely, extremely important to, control the entire manufacturing flow, starting from the design to the production and to the supply. Integrating metrology in the manufacturing process will further link the metrologist to the user community. It needs a very strong bond. The users need to know, understand the metrology, importance of metrology, and the metrologists need to make the users aware about the importance of metrology in every aspect of life. Also, if there is no data, if there is no data collection, then the industry 4.0 wouldn't be effective. Okay, the variation is detected early enough. It is possible to, if at all there are certain disturbances we can sense, then we can, in smart manufacturing, a corrective action can be taken to compensate them. Metrology systems collaborates with the real-time quantity information without compromising security. Very important. Real-time data collection is important, but securing that data, giving the accessibility to the right person is very, very important. The metrology solutions are excellently suited to ensure process stability. Flexible measure productions are there. We use various sensors and find out the measurement point, correct them so that the production is completely smooth and error free. So this is the bibliography from where the presentation has been made, and the data has been taken from all these papers. So here I would like to thank you for your patient hearing. I don't know, my voice is very bad.
Thank you.
We
No, ma'am,
tried.
your voice was very well. And we heard my request is kindly switch on your video and we can remove this presentation now. Thank you. It was a very insightful and very important presentation which you have made. Uh, I think that all the participants will be benefited from this presentation. My request is you kindly share this presentation to me so that we can share with all the participants, and we will place this video also on the Facebook as well as on YouTube channel. I would like to request all the participants to kindly switch on their videos and switch off their mics. If they wish to ask something or they wish to add or said something, you are most welcome. Anybody who wish to add? Dikshit sir, would you like to add something? Anybody else who wish to add? Certainly, we will share this presentation. Somebody has asked. We will share this presentation in the groups, WhatsApp groups and the Facebook, so that you can always see the presentation as well as the video will also be available. If anybody wish to add something, it's a very important presentation basically, which actually tells us about the importance of measurement, importance of this 17025, which is very important part for every industry as well as for every laboratory's life. So I would like to thank Ma'am Professor and BN Dikshit sir, our Honorable Director sir, the participants from India and outside of the participants. My request is if you wish to add or you want to speak on any topic, you are most welcome. We are always in the search of good speakers. Anybody who wish to add something? I think we are not audible. Anybody who wish to add or who wish to say something, add something, or some if you wish to ask anything, you are most welcome. Otherwise, we can, with the thanks, we can close this session today. Thank you, ma'am. Thank you, Dr. Gizamuna, ma'am, Dikshit Saab, and all the participants. We will meet next week with a new topic. Thank you. Thank you very much. Thank you. Good day. Bye. Thank you.
Yeah.